welcome to day 24 of our 30-day coding challenge from CS and Math. Today we decided to dabble around a little bit with growth sequence, in specific Fibonacci. Fibonacci is the one credited with this growth sequence. We're going to analyze how to append them or add them these numbers to a list, and then ultimately how the ratio approaches the golden ratio. Okay, so get ready on Trinket and let's jump into it. Okay, so depending on your kid's background, it could be good to say, hey, what is the structure? What are the steps? And obviously, if they've done some programming, they might know how to comment. So for Python, we're going to comment with the hashtags, and then that code won't execute for like line 1. So initialize the variables. We're going to call the first variable number 1. And we're going to set that equal to 0. And we're going to initialize number 2. Set that equal to 1. And then we should probably also initiate the list for Fibonacci. So I'm going to I'll just call it fib is probably fine. And I'm going to make it an empty list. So just to start a list, you just use the brackets. And let's see, so we've got initialize number 2. We got the Fibonacci. We should probably, well, we can leave that there, see if we need to come back and add something. But to add the first 2 numbers to the list, we use a method called append. So we'd say Fibonacci is the name of the list dot append, and then we would append number 1. I don't think you can do that with a comma. Maybe you can do it with a comma. I'm going to do it as 2 separate additions. So append number 1, append number 2. And then usually you want to try to spot check your code as much as you can. So to print over here to the console, we'll type print. You can use parentheses, you don't need them anymore. So print, if I print, we'll just print fib. So the title of the list is fib. So if we print fib at this point, we should see, click save here. We should see that those 2 numbers have been added. So this is the run, and notice that our list is the first 2 numbers of 0 and 1. So we've initiated those starting numbers, whatever they are. We've opened up a list. We've added those first 2 numbers to the list and then printed it. So now what we want to do after that is kind of iterate through the next 20 numbers. Like, what does the formula look like? And so for iteration in Python, we typically use a for loop. So for item, we'll just call it I in range parenthesis 20, colon. And the indentation, if you haven't done a lot of looping, is important. That means the stuff that's indented one level will repeat through. So for the items in range 20, essentially that just means repeat 20 times. Let's introduce a variable called next number. So we'll call it next number, and that's going to be equal to, we also will need to initiate, like a counter. So Python lists start at 0. So we're going to start this counter, this n value at 1. We could probably just do that in the first part of initializing variables. And so set the next number equal to, we're going to want to take the fib number bracket, not 0, because remember it will keep changing, but we'll say n, which is actually the first term, so technically the second term, plus Fibonacci of n minus 1. So if you think about what are those values, this is supposed to be plus. Think about what are those values. The Fibonacci of n, right, is going to be, if n is set to 1, is going to be 1. And the Fibonacci of n minus 1 is Fibonacci of the place 0 holder. So this is like the index of where they're at. So this is at the first spot. So again, we probably want to test that. And so just say print next num, just to test it. And if we ran that code, notice how it prints the next number as 1, which is the addition of these 2. I can test a couple different things, like I can change this to 2. I could run it, notice how it generates 2, 1, and then it's adding those together. And then sometimes you just want to keep testing your code out to make sure it just is doing what you thought it was going to do. If it didn't, change what is seeming to either produce errors or running into problems. And then to bump up so that this becomes 1 bigger and this becomes 1 bigger, you could do you could do this full thing where n equals n plus 1. Python also has a shortcut of n plus equals 1. That's just going to mean to increment that up by 1. So now if we run that 20 times and add, I guess after this one we should append next num. So we go to next num, we have to add that to our list. So next num, so we want to do fib dot append, sorry about that, and then we want to append next num. So now if we keep doing that and we've added this to the list, bumped it up, then I'll probably get rid of this print statement at this point and print fib right here. So if I run this code, it should print the Fibonacci sequence. So there you go. I'm gonna pause right there, let that sink in for a second, and see if you can clean up your code. Okay, so what I did then, hopefully got yours working. What I did is start the iteration through the ratios. So if you think about it, again, since this particular list starts with a 0, just like we did on the spreadsheet, we didn't necessarily want to take 1 divided by a 0. That would produce an error. So I'm just going to start the counter back at 2. So I can start cycling back through the ratio. I've initialized this new list for the ratio to store the values, or declared it, whatever you want to say, and then for item in range 20, now we're going to want to iterate through that division. So we'll set a new variable, let's call it ratio, equal to not the sum of a term plus its previous, but I'm going to actually just copy that for time's sake, just to show you can do that. We want the ratio, so we want to divide that out. So we want to take any term, here's the second term in the sequence, divided by the first term. Now technically, remember what that means then. Again, this is a 0 term, this is the first term, this is the second term. So this is going to take 1 divided by 1, because this is technically started off. Python starts up as a 0 term, just to reiterate. So then that's what ratio is equal to. Realistically, we should probably test it at that point, but to keep things kind of rolling, so we have the ratio set equal to the division. We're going to want to append that. So we do the ratio dot append, type ratio in there. So we're going to add to this list we called the ratio. I like to call it like the ratio, like the golden ratio, so that without giving away the term golden, if you haven't talked about it. If you have talked about it, you can just call it golden ratio. So we're going to append that, and then we're going to, again, increment up the counter n. So we do plus equals 1. And then just at the end, we're going to print it. So print the ratio. And so if I run this code, unless I have a typo in there, if I run this, it should add on those ratios. So 1 divided by 1 is obviously 1, 2 divided by 1 is 2, and you see it again approach the goal. Now this carries it out further decimals. And there's so much more you could do with this. There's a ton of stuff, but you've at least seen us doing some pretty important things here, programming through the variables and how to add them to the list. There's ways to clean up this display and whatnot, but hopefully that gave you some insight of things you could run with your kids. If you don't want to get into Python, I have included the Scratch code here, which is equally as good. It's just different platform. Notice then the ratios just print to visual lists. And if I, maybe I'll just make that smaller, make this bigger. Because the only differences are, like, we we had it at the beginning of our code in part of our initializing steps. We need to delete all of these lists because they stay out here in the stage. And Python starts at n equals 0. Scratch, the list starts at first term, so that's why we start the top code at 2. But everything else is the same in this structure. So I'll just pause right here. You can pause right here if you wanted to do this in Scratch. Get that code. And I will downsize that just a touch and get this bottom chunk. So there is Fibonacci code for Scratch if you'd rather use that approach. Again, hopefully you use this with your kids. Hopefully you find it good, and appreciate you watching. Thanks.